The Urban Heat Island Effect by Natalie, Carro, and Michael Piazza. Most of the people in the world live in cities. It is estimated that 55% of the world's population are city dwellers. That's around 4 billion people going about their day, not thinking much about how the urban heat island effect impacts their daily lives, or what sort of impact they have on it. It is expected that the percentage of people living in cities will increase to 68% by the year 2050. That would be over 6.7 billion people. This is a chart that shows the projection of the city-dwelling population in the future. The urban heat island effect refers to the ability that cities have to absorb and retain heat, even after the sun has set. The urban heat island effect can cause a city's internal boundary layer to be between 6 to 8 degrees Fahrenheit hotter than its surrounding areas. The urban heat island effect results in higher energy consumption in the form of air conditioning costs, and also causes an increase in what is known as waste heat, or the emission of air pollutants and greenhouse gases, as more power is needed to cool the surface. This is otherwise known as the cascade effect. The urban heat island effect also increases the risk of heat-related illnesses and/or mortality, such as heat exhaustion or heat stroke. The urban heat island effect impacts our quality of life as well, as elevated temperatures cause discomfort, and along with higher air pollution, respiratory diseases. The urban heat island effect also impacts the ecosystem and the demand for water. Hot surfaces transfer the absorbed heat to rivers, lakes, streams, and ponds, increasing surface water temperature and affecting the aquatic ecosystem as well. Now that we know what some of the risks are that are associated with the urban heat island effect, let's look at what really causes it to happen in the first place. For starters, the lack of vegetation and the impermeability of surfaces are major factors in the urban heat island effect. Not only do trees and plants provide shade, but the more trees and plants there are, the more evapotranspiration occurs. Evapotranspiration actually describes two processes: evaporation and transpiration. It's how moisture moves from the soil, through the plant's vascular system, and into the Earth's atmosphere. Whenever moisture evaporates from the soil, or is transpired from the leaf of a plant, it affects sensible and latent heat transfer. When the transfer of energy as latent heat, which is the energy that is required to change the phase of a substance such as water, exceeds sensible heat transfer, which is the heat that you can physically sense, most of that heat energy gets consumed by the process of evapotranspiration. Urban surfaces, such as streets and sidewalks, are impermeable to water, and this creates a rerouting of precipitation. This reduction of available water increases sensible heat by reducing latent heat transfer and thereby increasing the temperature of the city. Another cause of the urban heat island effect is the change in surface geometry and the predominance of the color gray. These two characteristics, typical of urban buildings, change the receipt of solar radiation. Darker buildings and roofing materials absorb more sunlight than light-colored ones do because they have lower albedos. The albedo is the percentage of visible light that is reflected by an object or surface. The presence in many buildings also causes multiple reflections to occur, and the sunlight is scattered back and reabsorbed repeatedly, making the albedo of the entire area lower than the individual surfaces within it. Perhaps the biggest and most important impact on the urban heat island effect is population. There is no doubt that the more people there are within any given location, the greater the increase in temperature due to the urban heat island effect. Specific human activities do play a role in these temperature differences, but none so much as the sheer size of the city, its population, and its population density. These are some charts comparing the size, population, and population density for Miami-Dade, Broward, and Palm Beach counties. Now look at the average monthly temperatures between South Florida, Miami, Broward, and Palm Beach counties, you can see the city with the highest population also has the highest average monthly temperatures, which is Miami. This video shows the movement of heat storage throughout South Florida over the course of 24 hours. You can see how the heat stays concentrated at night over the most populated areas of South Florida, such as Miami. Another reason for the urban heat island effect is air pollution and greenhouse gas emissions, such as carbon dioxide, nitrous oxide, and methane. Anthropogenic sources of these greenhouse gases, such as vehicles, air conditioning, and industrial processes, all contribute to the overall warming of the city by increasing the amount of greenhouse gases that are already in the atmosphere, gases which absorb the outgoing long-wave radiation emitted by the surface due to the incoming solar energy from the day. As the surface is warmed during the afternoon, heat is conducted downward. When cooling occurs at night, the stored energy is released to the surface. Urban particulates and greenhouse gases both keep the heat that would normally be able to escape out to space trapped within the urban boundary layer. Urban particulates can absorb and scatter incoming solar radiation, and even though these particulates tend to block and decrease the overall amount of solar energy coming in, it is not enough to offset the amount of long-wave energy that is being absorbed. These are some charts that show how this process favors higher nighttime temperatures. South Florida average day-night temperatures for the month of February 2020 compared to Miami-Dade, Broward, and Palm Beach counties. Again, you can see that Miami exhibits the greatest amount of heat retention when you compare its daytime and nighttime temperatures with the other areas. These charts of Miami Beach and North Miami average day-night temperatures further show the impact of population on a city's microclimate. Miami Beach, with its slightly higher population, displays slightly more heat retention than North Miami. Finally, what are some ways we can help to mitigate the negative impacts of the urban heat island effect? Number 1, green infrastructure. Now, more than ever before, there is a big focus on green infrastructure. The concept of a garden city, an urban planning idea first proposed by Ebenezer Howard in his book Garden Cities of Tomorrow in 1902, is just now being implemented in cities such as Singapore and Dubai. They have done this by maximizing the green space within the city, parks, rooftop gardens, vertical garden walls, and tree-lined streets, for example. Number 2, sustainable development. The use of sustainable design techniques that keep buildings cooler longer reduces the need to use more air conditioning, which releases greenhouse gases such as chlorofluorocarbons, or CFCs, into the atmosphere. The use of renewable resources, such as solar energy and hybrid petrol-electric vehicles, reduce the need to burn fossil fuels, which releases carbon dioxide, yet another greenhouse gas. Number 3, carbon removal. This term refers to the many different strategies that involve the capture and sequestration or storage of atmospheric carbon dioxide. One method, called CO2 scrubbing, involves using calcium oxide to absorb CO2 mixed with steam from the atmosphere, and then releases it at 1,000 degrees Celsius. The stored CO2 can even be used as a renewable energy source. It still remains to be seen whether any of these strategies can have an impact on the urban heat island effect or global warming in general. Number 4, citizen incentives. Cities that encourage citizens to carpool and utilize a more sustainable public transportation system, such as electric buses, trains, and trams, have a less negative environmental impact than those that strictly use fossil fuel energy. Because the truth is that most people don't care about the urban heat island effect, but hopefully with the right policies and incentives in place, they won't have to.